Sorry, tonight's video is section 2.1 on differentiability. Your homework is as listed. Yes, there happens to be some for the next section, 2.2. There are 2 problems. So we have a lot of notes this evening. First thing I want to do is review what we have already learned. That the first derivative, or the slope of the tangent line of the graph of f for any x, is this limit definition here. And this is really just slope. It's really just y2 minus y1 over x2 minus x1. So here's my 2 points, and I really want to know the slope of the tangent line at this particular x. It could be for any x, though. I can move that x anywhere. But it's between these two, it's this one here. And so this is my x2 minus x1. When you subtract this minus this, I'm going to get just my delta x. And then this is my y2 minus y1. It's really just slope. And remember, what I'm doing is I'm really taking 2 points, and I'm going backwards and backwards and backwards. I'm decreasing that distance. I'm decreasing it. So actually this is coming back because I'm going to find the slope of the tangent line of this point. So this one I just keep dragging back. That's what the limit does. So tonight we're going to have the alternative form of the derivative at x equals c at a particular value. So the slope of the tangent line at c, the slope of the tangent line, the graph of f at c, is this limit definition. This is just an alternative. This too is y2 minus y1 over x2 minus x1. And here's its picture. So I'm just changing it up. Instead of calling this x, I'm going to call this c. And so I'm going to be taking this x and approaching c. So it's going to be getting closer. I want to get closer and closer and closer to c. So again, I want the slope of the tangent line to the graph of f at c. There's my c, there's my x, there's my f of c, my f of x. So it's y2 minus y1 over x2 minus x1. Limit definition. Just I wrote these a little bit different. So this looks a little different. And so in this alternative form, this is true if from each side it is true. From the left and from the right. From the left and the right. And you'll be seeing examples of this in a moment. F is differentiable. In other words, I can take the derivative if the derivative from the right and the derivative from the left both exist. And we're going to do that in problem number 93 today. So f is differentiable if the derivative from the right and the derivative from the left both exist. So again, I'm going to be giving you some information, and then we'll work it through with a few problems. So if it's differentiable, then it implies it is also continuous. So if f is differentiable at x equals c, so at that particular x value, we'll call it c. If it's differentiable there, which means this is true, then f is also continuous at x equals c, which means I can pick up my pen. I don't pick up my pen through c. It's continuous. I continuously keep writing. But please note, it is not true the opposite way. If f is continuous at x equals c, then f is also differentiable at x equals c. This is not true. You can't go backwards. So continuous doesn't imply differentiability. Only differentiability implies being continuous at x equals c. let's show why it is not true. I have two exceptions. Here's the two exceptions. If there's a sharp turn, so look at it is continuous here, it is continuous here, but it is not differentiable there, and it is not differentiable there. Also, when a graph has a vertical tangent, so right here, as I roll my pin around, right at this value right here, my pin would be vertical. That is undefined. I am unable to take the derivative of this. So I cannot take a derivative when there's a sharp turn, and I cannot take a derivative at a point that the slope of the tangent line is undefined, or in other words, it is vertical. So even though these are continuous, they are not differentiable. But if f is differentiable, then f is also always continuous. So let's try an example. Let's do example number 73. It says I'm supposed to use the alternative form of the first derivative. And the alternative form is the one with c. In fact, they tell me let c equal -2, which is my x value. So this is what I want to find. The first derivative of f at -2, I must use this new alternative form, the limit definition. F of x minus f of -2, x minus a -2, whatever I'm approaching, whatever that c value is. And so I took f of x just the way it was, subtract, now put in -2 wherever I see an x. So this maintained. I did this math. I continued to clean it up. And so +1 and -1 is gone. Again, I cannot find this limit right now because if I put in -2, it'll be 0. So I need that factor of x plus 2 to go away. So I'm hoping I can find a factor in the numerator that's x plus 2. In fact, I can. I can factor out an x squared out of both. I'm left with the x plus 2. There's my common factor. So now I can take my limit, -2 quantity squared equals 4. So I just found my limit at -2 on the graph of f. 4 is the slope of the tangent line to the graph of f at x equals -2. Remember, I'm going fast because I'm trying to keep these videos as short as possible. I know you're going to have to stop these a lot and probably rewatch them to see what I'm talking about. Number 93. So now I have a piecewise function. So I'm supposed to, in the directions it says, find the derivative from the left and from the right. Well, if I do the left and the right, I must use the alternative form of the first derivative. That's one with f of c. So I'm going to go ahead and find the limit. So I'm trying to find this. In order to do so, I'm going to use the alternative form to go left and right. So the limit as x is approaching c from the left. Here it is. And then from the right. So this looks the same, just it's different from the left and from the right. So I'm going to use different pieces of the function. And so here I just sketched it out. So I can see I did the math too far down there. Let me try it up here. So the limit as x approaches 1 from the left. 1 from the left, that's x minus 1 quantity cube. Put in 1, it's going to be 0. The limit as x approaches 1 from the right. 1 from the right is x minus 1 quantity squared. I'm going to go ahead and find that limit. That 2 is 0. So because these both exist, then f is differentiable at 1. Because from the right and the left it does exist. Now, this pertains to the homework in section 2.2, 113 and 114. We have seen something like this before, except what it told us about it is different. So I have my piecewise function, but notice it has my a's and b's. Look what it's saying. Find a and b such that f is differentiable everywhere. When we did these back in chapter 1, we said find a and b such that f is continuous everywhere. Now I'm saying it's differentiable everywhere. And we know if it's differentiable, it is also continuous. So in order to find that a and b, I am going to assume f is differentiable. Therefore, f is continuous. So that means I need to use the alternative form of the first derivative so I can go from the left and right. So I'm trying to find the first derivative of 2, f prime of 2. So I'm going to go ahead and go from the left first. F of x minus f of 2, x minus 2. So I filled in c with 2. I only put the left and right here. Here I just drop in a 2. So now I have to go get the right piece of the function to do 2 from the left. So 2 from the left would be this one here. So the limit of x squared minus 2x plus 1 minus, then I put in 2 for all of these pieces, and I actually get I get a negative 1 over x minus 2. Sorry. Then as I clean that up, it's x squared minus 2x and then I'll factor out the x, and x minus 2 cancels top and bottom, so that is 2. Now I'm going to do it from the right. So the only place I'm going to show it is here. This is still all the same, except I pick a different function. It is the other piece. It is ax plus b. I think I see what I'm doing. I think I might have an error. It looks like it's negative 2. I think that's what I need to be saying here. In which that is x plus 2. Well, I think I need to redo this problem. Sorry about this. Let me go ahead and go through this. I will recorrect it tomorrow. I want to go ahead and finish up this video. So what I'm going to do is I'm going to go to the left and I'm going to go to the right. And what I should be able to do out of this, from again, it said that it was differentiable, is that the left and the right should equal one another. And I should be able to find one of the letters. But how am I going to find the second one? Because what happens is the b's cancel out in here, negative b and a positive b. So then what I have to do is, if f is differentiable, in which it is, then so is f as being continuous. Then I have to go ahead and use those steps. Remember the steps for being continuous? Step 1, I have to go find f of 2. So for 2, I pick that right piece, and I get 1. Next, the limit of f of x must exist. So I'm going to go from the left and from the right, and those two are going to be equal to each other. And I already know what a is. We found out up here that a is equal to 2. You substitute it in, and then you're able to find the other one. So I will rework this one and hand it out to you tomorrow in class. Thank you.